Okay, we want to start our look at basic function graphs. We'll look at basic linear and basic absolute value functions in this video. So the first linear function will be f of x equals x, which is the same as y equals x if you take away the function notation. And so to graph this, I'm simply going to set up a table of values for this function. And I'm going to call this basic because really there's no calculation to figure out the y values. And for no particular, well, for a reason, I'm going to definitely plug in 0 for x because that's sort of in the middle of a graph. And then I'll plug in values on each side of x. Okay, so -1, -2, -3, and 1, 2, and 3. And of course, I know that I could plug in all kinds of other x values, but what I'm trying to do here is learn the behavior of this function so that I can imply what the rest of the graph looks like. So if x is -3, and I know that y equals x, then I know that y equals the x value, which is -3. And similarly, if x is -2, because of this equation, I know that y also equals -2. And then the same is true for the rest of these values as well. The y values equal the x values. And what each of these gives us is an ordered pair. So we get the ordered pair -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, and finally 3, 3. And so now I want to plot those points and see if I can sort of understand the behavior of this function as well as imagining other points in this table if necessary. So I've set up a coordinate plane here, and I've indicated that each tick mark or each grid mark here is 1 unit, and I need to plot these points. So 0, 0 is right here in the middle, the origin. So I'm starting there at the origin, and then I'll work to each side. So let's do the positive ones first. When x is 1, y is 1. Then I get 2, 2, 3, 3. And you can imagine if x is 4, because in this equation y equals x, if x is 4, y is also 4. And so this graph will continue forever in this direction like this. And in fact, even if you imagined x values between like 1 and 2, if x were 1.7, which would be like in between 1 and 2 here on the table, 1.7, y would also be 1.7. So you would get this point like right here. So it's true even between the whole number values, okay? That's important to think about as well. Okay, let's go to the left. If x is -1, y is -1. If x is -2, y is -2. If x is -3, y is -3. And you can start to see that the y values being equal to the x values result in a similar shape on the left side of the graph. And so on the left side it goes like this. And so the linear function gives us a line, and this is called a linear function because x is to the first power, okay? And when your variable x is to the first power, you're going to get a slanted line, which is what we have here. In particular, it goes through the origin. You can calculate its slope as 1 if you know how to do that. But there's our standard linear function, f of x equals x. Now we look at a similar function. It's called the absolute value function. And absolute value is indicated by these vertical bars around whatever you want to take the absolute value of. These vertical bars, by the way, are on a keyboard, usually like above the enter button. It's the same button as backslash, okay? But anyway, let's do the same thing we did before. Let's make a table of values, understanding that this equation is the same as y equals the absolute value of x. And let's use 0 again right in the middle of the graph, and then let's look on each side. So -1, -2, -3, and then 1, 2, and 3. And if I were to plug 0 into this equation, then my y value would be the absolute value of 0, which is 0. And so all my y values are absolute values. The absolute value of -1 is +1. The absolute value of -2 is +2. The absolute value of -3 is +3. The absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of 3 is 3. So you see now it's somewhat interesting. You get, you still get your 0, 0, your 0, 0 order pair here in the middle. And then your y values are the same on each side of 0. That's a little bit different than what we saw before. Okay, so let's see what this means about the graph. Let me go copy the plane that I had before. And let me label my intervals here. So this would be 1 again, and this will be 1, and this is the origin, or where 0 is. Okay, and let's plot the points. So I'll start with 0, 0, which is the origin again. And then let's do the positives. 1, 1, 2, 2, 3, 3. Hey, that's just like the line we looked at. But on the left side, if x is -1, y is +1. And if x is -2, y is +2. -3 gives us +3. And in fact, if I kept going, -4 would give us +4 because the y values are the absolute values of the x values. So our graph, instead of going down here like the line did before, we don't do that. The y values have to be positive, so this side of the graph is sort of turned up like this, and now goes back in the upward direction, just like the right side did. And so the absolute value function gives us a V shape. It's very similar to the linear function, except none of the y values are negative. So you get this V shape. Okay, so that's your standard linear and standard absolute value function graphs.